Welcome to EDU World Space.
All right, guys, we're doing problem 80 of chapter 9 in Chemistry Central Science. So if we assume the energy level diagrams for homonuclear diatomic ions shown in figure 9.43 can be applied to heteronuclear diatomic molecules and ions, we predict the bond order and magnetic behavior of these molecules. So let's go here. Yes. So we're going to start with CO plus. So we first have to look at the electron configuration of carbon, which is helium 2s2, 2p2, and oxygen 2s2, 2p4. Now we're going to have since we have a positively charged ion, one of our atoms is going to lose an electron. In terms of like what we draw on our diagram, it doesn't particularly matter. So I chose oxygen is going to lose that atom. So now we have our non-bonding our electrons in our non-bonding orbitals. So we're going to put that into our bonding orbitals. So we fill up. So we have 5 electrons in total. So we have 2 in our sigma bond, so 2 in our sigma orbital, 2 in our pi orbital. And 1 in our other pi orbital. So then, so you can see that we have 1 unpaired electron. And so that means that we are going to be paramagnetic. Now we're going to look at our bond order. So if we look at our bond order, we have filled up electrons in our sigma orbital and also in one of our pi orbitals, and we are half filled in the other pi orbital. So our bond order is going to be somewhere between 2 and 3. So let's approximate it and say 2.5. Now let's look at NO. So we have our nitrogen with 3 electrons, and we have our oxygen with 4 electrons into p orbital. And then we have another electron because we have NO minus. So now we, as I just gave that to my nitrogen. So now we take our electrons in our non-bonding orbital. We're going to put them in our bonding orbital. So we're going to have fill up our sigma, both our pi orbitals, and then put an electron in each of our anti-pi orbitals. So it looks like that. It looks like the bond. Well, first of all, our substance is going to be paramagnetic because we have unpaired electrons in our anti-pi orbital. And our substance is going and our bond order. We have filled out the orbitals for single, double, and triple bonds. However, we have 2 electrons in our anti-pi orbital. So these 2 electrons are going to weaken our bonding. So you can approximately you can think of each electron in anti-pi orbital as dropping our bond order down by 0.5. So if we have 2 electrons in our anti-pi orbital, and without them, our bond order would be 3. Our bond order should be approximately 2 in this case, because we have enough electrons in our anti-bonding orbital to break that triple bond and form a double bond. And these are just like estimates of the bond orders. Now, for OF plus, we have electronic structure of our oxygen and our fluorine. So since it's OF plus, one of them is going to lose an electron. I chose fluorine. So then we have it set up like this. We have oxygen. we have oxygen and fluorine. We fill our bonding orbitals, so we fill both our pi orbitals and our sigma orbital, and then we fill up our anti-pi, half-fill both of our anti-pi orbitals. So you can see that they're unpaired electrons, so this is going to be paramagnetic. I'm just going to abbreviate it as para. And our bond order, we fill enough orbitals for a triple bond, but we have 2 electrons anti-pi bonding orbital, so our bond order is approximately going to be equal to 2. So this is going to be similar to O2 in terms of electronic structure. So now we have neon fluoride, a positively charged ion. So this is the electronic structure of our neon. So we put our non-bonding orbitals here. We have to take 1 electron away from the neon because we have to have something that's we lose an electron for a positively charged ion. So now we're filling up so now we take our non-bonding electrons and fill up our bonding orbitals. We fill up our sigma, both our pi orbitals, and we can have enough electrons to fill up both of our anti-pi orbitals. So this is not para, this is diamagnetic, which means that there are no unpaired electrons in our bonding orbitals. And we can see, and for the bond order, we have enough electrons in our bonding orbitals to form a triple bond, but let's see how much we have in our anti-bonding. We have filled up both of our anti-bonding pi orbitals. So that's going to break that's going to cancel out both of these sigma bonds, both of these pi bonds. So our bonding order is going to be close to 1. We should have a single bond in this case. So to do this kind of question, you have to understand paramagnetism. You have to understand the molecular orbital diagrams. You have to understand how to set those up using the electron configuration of the atoms that you're using. That's how you solve this kind of problem, and that's how you can understand how to apply the molecular orbital model for looking at various kinds of specific molecules.